Hi, my name is Amir Tataibi, an assistant professor of biomedical engineering. And in this series, we talk about physiological systems in biomedical engineering. Today, we want to use MATLAB in order to solve a system of curves for the ODEs like this set of equations here. Here we have two equations and two unknowns, QA and P1. And all other parameters in these two equations, including RA, LA, C1, and delta P, these are known. If we define y such that the first element of y is QA and the second element of y is P1, then dy would be dQA over dt and dP1 over dt. Look at the left-hand side of these two equations. We have dQA over dt and dP1 over dt, which is basically our dy over dt. Also, if we replace all the QAs and P1s that we have in these two equations by y1 and y2, we get this new set of equations, which is basically the same set of equations that we had. In MATLAB, there are different built-in functions that we can use in order to solve these equations using this syntax here. In this syntax, we need to define the initial conditions, the vectors specifying the solution interval, a function that contains the derivatives, and then by running this syntax here, we can find the solution for our ODEs. There are different solver algorithms, as I mentioned, like ODE 45, which we are going to use today. So let's start with this function containing the derivatives and see how we can build it. If we write the first equation that we have in this set of equations here, in MATLAB syntax, we get something like this. And then for the second equations, similarly, we get this equation here. Now, in these equations, we said that we assume RA, LA, C1, and delta P are known. Let's give them some random values. And for delta P, let's define it as a sinusoid function such that delta P equals A sine of omega t plus B, and then we define A, B, and omega. This is the function that we need here. I give it a random name, for example, MyFund, and MyFund is the function that we need in this syntax. We need to define another function that calls MyFund here and then uses this syntax in order to solve the ordinary differential equations that we have here. So in this function, we need to define the time interval. We need to define the initial conditions. We know that we have two unknowns, therefore we need to define a vector of initial conditions that contain two elements. Let's say that the initial conditions in this case is 0. And then by running this script, which contains these two functions, the first function and the second function here, we get the solution of the set of ODEs that we originally had. We can also plot the solution using the plot function of MATLAB. For example, for the parameters that we defined here, we get some graphs for QA and P1 like this. If we modify these parameters, for example, using different values for RA, LA, and C1, we get a different solution. Also, we can use a similar method for more number of equations and unknowns. For example, 4 equations, 4 unknowns, and we get the solution for all of those unknowns that we have in our equations. Thank you for watching this video. Bye.